Okay, so more probability today. First, this idea of dependent or independent events. So if one event has an effect on the other event, then they are dependent events. So let's look at a couple events and just kind of figure out if they are dependent or not here. So let's see. So this first one, roll a die and then spin a spinner. So if I roll a die, roll a 5, does that have any effect on when I spin a spinner and, spin a 7 or something? They have no effect on each other. Those two events are independent of each other. So if one has no effect on the other, they're independent events. However, if I pick a card from a deck and then pick a second card from the deck, the probabilities have changed. For example, if I want to pick the ace of clubs, that's 1 out of 52 for the first chance of doing it. If I pick the second card, now there's only 51 cards left, so the probabilities for picking any particular card will change for that second card. So those are dependent events. The first event, picking a card, definitely has an effect on the probability of the other event. So those are dependent events. So this one is independent here. So this one is independent, and this one is dependent. So if two events are independent, this is the basic formula. This may look kind of like gibberish, but this is the formula we use. So it's basically saying if I want both events to happen, event A and event B, then I just take the probability of A and multiply it by the probability of B. Okay, let's see. So let's see if we can use this. There are 14 red velvet cupcakes and 6 lemon cupcakes. There are also 8 sugar cookies and 12 snickerdoodles. Ugh, getting hungry. If you grab one cupcake and one cookie without looking, what is the probability you get a lemon cupcake and a sugar cookie? Before we answer this, are these independent events? Picking a cupcake should have no effect on picking of the cookie here. And so I think these are independent. So we can say the probability of A, which is cupcakes. So this would be probability of A. Let's see, I want to pick a lemon cupcake. So that would be 6 out of 20 times probability of B. B is picking the cookie in this case. I want a sugar cookie, and that would be 8 out of 20. And then just get your calculator out, multiply those, make sure that and so if you type that in your calculator, you get 3 out of 25. Of course, that's a simplified answer there. You always want these in simplest form. So 3 out of 25, which is about like a 12% chance of that happening. So those are independent events. Two events that can't happen at the same time. So this is a different concept, are mutually exclusive. So if they literally can, if the two events cannot happen, there's a 0% chance that that's going to happen. Those two events are impossible to happen together. So if you roll one die, notice one die here, not two, but one die. Can I roll both a 5 and a 6 if I roll one die? Not two die, but one, not two dice, but one die there. That would be mutually exclusive. So you either get a 5 or a 6, you can't get both here. So that's not really possible. Rolling an even number and a multiple of 3. Okay, so there's even numbers would be 2, 4, and 6 when you roll a die. Multiples of 3 would be 3 and 6. Can I have both of those things happen at the same time? If I roll a 6, that satisfies that and this. So that is possible. Those two events are not mutually exclusive. I think 1 out of 6 times I would actually have that event be true. So that is not mutually exclusive event. If you do have mutually exclusive event, then this is the basic formula. You just add up their probabilities. Very easy. If they're not, you have to subtract this overlap here. There's a couple different ways of seeing this, but let's see what type this is. So first, let's decide if this is mutually exclusive or not. A single letter is chosen at random from the word cupcake. What is the probability of choosing an E or a vowel? So, and this is for an or statement here. Both these formulas are for or statements. So, is this mutually exclusive? Can I do both of those things at the same time? A vowel is A, E, I, O, U, sometimes Y. So there's no U's, there's no O's, there's no I's. There is an A and an E in this cupcake word, and there's an E here. So those two events are not mutually exclusive. There is an overlap between those two things. So here's what you would do. You go, okay, let's kind of draw it out here. So this is an E over on this side, and this is a vowel. And there is one letter that is overlapped. There's one letter that is both an E and a vowel at the same time. E is both. There are two vowels. So there's one that is out of these letters. There's only one other vowel. Oh, there's a U. Sorry, I didn't see poor U. So this is actually two other vowels. So there's a total of three vowels in the circle here, but two of them are not E's. There are no E's that are not E's. It's kind of a weird thing to say that are not vowels. So there's essentially zero over here. So the OR, what the OR does is this. Let's just kind of use the formula. In other words, the probability of this happening is if I choose one letter, 1, 2, 3, 4, 5, 6, there's 7 letters. So 3 out of the 7 will give me the answer I'm looking for, either an E or a vowel. I'll get that 3 out of 7 times. So that's the actual answer to the problem. The way to do it using the formula is this. Because these are not mutually exclusive, this is the formula. So this would be probability of A is 1 out of 7, plus probability B is the vowels, which is 3 out of 7, minus the probability of A and B is the overlap. There's one case that's the overlap, so minus 1 out of 7. So you get 4 out of 7 minus 1 out of 7 is 3 out of 7. So you get the same answer using the formula, but you basically have to not count that number twice, right? We go, okay, so when we did this 1 out of 7, that's both of these. We did this 3 out of 7, that's both of these. And you can see we kind of double counted this number here in the middle. And so we've got to subtract it. We can't count that number twice. So we just kind of subtract it. There's two ways of viewing that, but I really like the Venn diagram way of doing it. Let's look at another one. A single letter is chosen at random from the word cupcake. What is the probability that it's E or U? Are those two events mutually exclusive? Yes, they are, because you cannot have both an E and a U at the same time. So according to the formula, you just add up the two probabilities. So the answer to this question would be 1 out of 7 plus 1 out of 7 for getting a U is 2 out of 7. I don't have to subtract anything. There's no overlap between the two. I'm just adding up the two probabilities. So you just add when it's exclusive. When drawing a card from a deck of 52 playing cards, the probability of getting a red card or a king. By the way, you should know the basics of a playing card deck. There are 52 cards in a deck. There are two suits that have 13 cards each in them. One of them is clubs, and one of them is spades. And then there are two suits that also have 13 cards each in them. One of them you may know is hearts, and one of them is diamonds. Okay, so I want to get a red card. So the probability to get these, by the way, hearts and diamonds are red, and clubs and spades are black. So red card. So I'm going to draw a Venn diagram. I think this just makes sense in this case. So red card over here and king over here. So are there any red cards that are also kings? So there's going to be a king of hearts and a king of diamonds. There are two cards that are both red and king. I always start in the middle. How many cards are kings but not red? So there'd be a club and a spade. So there'd be two cards that are kings but not red. How many red cards are not kings? So there are a total of 26 red cards, 13 plus 13, minus 2 is the overlap. So the 26 minus 2 is 24. There are 24 cards that are red but not kings. So what's the probability of drawing one card from the deck? So out of 52 is obviously the total down there. If you just add these up, 24 plus 2 plus 2 is 28. So 28 out of 52, that'll be what, 14 out of 26, which is 7 out of 13 if we simplify. And so that's the answer to the question. We could have gotten this with a formula. We could have said the probability of red, which is that plus that, that's 26 out of 52, plus the probability of kings, which is 4 out of 52, minus the probability of the overlap, which is 2 out of 52. And I think if I did that, I would get what 30 minus 2 is 28. So we get that right number, 28 out of 52. And you get the same answer of 7/13 doing it that way as well. And that's the end of the screencast.